Welcome to the another video of rational numbers. In previous video we solved example 5 without using commutativity and distributivity. So in this video we will solve this example again by the two property, commutativity and distributivity. Okay, let's see example 5. So what was the question? Question was that 2 by 5 into minus 3 by 7 minus 1 by 14 minus 3 by 7 and into 3 by 4. First we make group where multiplication is in between two rational numbers. So one group is this and one this. So let's write as 2 by 5 into minus 3 by 7 minus 1 by 14. Here 3 by 7 into 3 by 5. Let's recall what is commutativity and distributivity. So if we have commutativity means change the order and answer will not be changed. Okay, if we have, and this commutativity property holds in multiplication and addition only, not in subtraction and division. And distributivity, it is not hold but it is one type of property. Then you can do this. Okay, if we have A, B and C, and this A dot means A multiplied B plus C, then it can be written as A into B. A into B dot means multiplication, A dot B plus A dot C. Okay, this looks nice. Rather than writing A cross B plus A cross C, you can write dot instead of this cross. Okay, so this is distributivity. Okay, you can distribute this A to both of this B and C. Okay, whether change without changing answer. Okay, answer will be not changed. Now let's first we see commutativity. Okay, let's see commutativity. Here see, you can see this 3 by 7 and 3 by 7, but here is minus 3, so we can write, we can apply this minus sign to this 2, and this minus 3 will convert into 3. So minus 2 by 5, and because answer will be not changed. Okay, 2 into minus 3 is also minus 6, and minus 2 into 3 is also 6. 3 by 7 minus 1 by 14, 3 by 7 and 3 by 5. Here in, okay, let's write together. This 1 by 14 we write in the last. Minus 2 by 5, 3 by 7 minus, this is order. Okay, if we change, okay, we changed the order of this two. Firstly 1 by 14 is first, and after then 3 by 7 and into 3 by 5. But if we change the order, if we write first it and then this, then answer will be not changed. Okay, because see, these two rational numbers are in addition. Okay, because here these two are in here these two are negative numbers. So if we change the order, then the answer will not be changed, because we add two rational number if they have negative signs. But if okay, negative signs, okay, we change the order of number with its sign also. Okay, with sign also. It means that if we have A minus B and we write B minus A, then it is, we changed order without its sign. If we write this minus B plus A, then it is changed order. Order is changed with its sign. Okay, we changed order with taking its sign. Okay, we write B with minus, because here B is negative, so we write minus B, not B only, because if we write B minus A, then answer will be changed. It is not equal to A minus B, but this is equal to minus B plus A. Okay, we write first minus B and then plus A. Okay, so meaning is same. Here it is changing it is changing process with sign, and it is without sign. Here first sign of B is minus, and after changing the order of B and A, here we see the sign of B is changed. It is not valid. It is valid. Okay, so we can write 3 by 7 into 3 by 5 with its sign first and minus 1 by 14. Then answer will be not changed. Now in multiplication we can also change the order. Okay, we can interchange the positions. So 3 by 7 and minus 2 by 5. 3 by 7, this is basic things. Okay, here we used, you can write, here we used, okay, here we used commutativity. Okay, minus 1 by 14. Now this 3 by 7 can be taken common out. Okay, so let's 3 by 7. Here 3 by 7 will be taken outside, so there will 1, so 1 into minus 2 by 5 is minus 2 by 5. Now minus 3 by 7 will be common out, not minus 3 by 7, only 3 by 7, and here will be 1, so 1 into 3 by 5, so 3 by 5 minus 1 into 14. Now, so this is distributivity property. Okay, we can distribute also, and we can take common out number also. So this is commutativity, distributivity. Now here see, both the denominators are same, so we can add numerators. Why we here add? Because the numerators are negative, minus 2, minus 3, and if we have two negative rational numbers, then we add them. So add 2 plus 3 is 5, but answer will be negative because bigger magnitude has negative sign. Minus 1 by 14. Now here again we use distributivity as y. See, if we, okay, no, it is easiest. Yes, this 5 and 5 will be cancelled out. Okay, I said that. Okay, if there is same number in numerator and denominator, then we can cancel it out. Okay, so 5 be cancelled, then there is minus 1 by 14. Now this is 3 by 7 into minus 1. Okay, if we multiply any number with minus 1, then number will convert into what? Additive inverse. Okay, this is 3 by 7. If I write answer of this multiplication, then it is minus 3 by 7, and this minus 3 by 7 is additive inverse of 3 by 7. Okay, it is not part of this process, but I am telling you that I am recalling what is additive inverse. Now here we have to make denominator equal. So if we multiply and divide by 2 here, then denominator will become 14. So this is minus 6, 14. Now we can add these two denominators, minus 7 by 14. So we can factorize this 14 into 7 into 2. Here 7 cancel, and our answer will minus 1 by 2. Okay, so we changed the process, but our answer is not changed. Okay, so the process becomes simple when we use this property, commutativity and distributivity. Now let's see another example. Okay, example 6. Okay, example 6. So write any three rational numbers between minus 2 and 0. Write any three rational number. Okay, and we saw one process for making it easier, okay, to finding rational numbers randomly. Okay, we can write randomly also that three rational number between minus 2 and 0, it is minus 1, which is greater than minus 2, minus 1, then minus 0.5, minus 0.7. So these three are rational number, but the It is 3. So we can write on any 3 rational number in between -2 and 0. So we use that method of taking mean. So first let's, it is -2 and 0. If we take mean of these two, then we will get one number between these two, and let's take it is A. If we take mean of this two, then we will have another number B. If we take mean of this A and 0, then another number we will have. So finally we will have 3 rational numbers, which will be answer of this question. Any 3 rational number between -2 and 0. In book you can see also there is another solution. So let's see this. First we take mean of -2 and 0. So -2 plus 0 by 2. Okay, if we add 0 in any number, then answer is that number -2. Okay, see, this -2 can be written as -1 into 2. Now here in there is 2 in numerator and denominator, so we can cancel it out, and our answer is -1. Okay, never put 0 in the denominator after cancelling out this 2. Okay, this is representation of division. Okay, if you divide 2 by 2, then it will come 1, but simply we can make cross mark, okay, rather showing division. So this is -1. So now we have one rational number between -2 and 0 is 1. So now, okay, you do not require to show this number line. Okay, you all only require to write how you find rational numbers between -2 and 0. Okay, you should not write directly these are rational numbers. No, you can, but if your question will be, let's say, 2 marks, then you cannot write directly. Okay, now so -2, -1 and 0. Now we will take mean of this two, -2 -1 and by 2. We have two negative numbers, then we add. So 2 plus 1 3, and our answer will -3, because our bigger magnitude has negative sign. So -3 by 2. So this is second rational number in between -2 and 0. So this is here -2, -3 by 2, 1 and 0. Now we take mean of these two, 1 and 0. So we will get one rational number between in this two, and finally we will have 3 rational number between -2 and 0. Now let's take mean of 1 and 0. So it is not a big deal. 1 plus 0 by 2 is equal to 1 by 2, and another rational number is 1 by 2, and now finally we have 3 rational number. So we can write finally that any three rational numbers between -2 and 0 are 3 by 2, 1, not 1. Why I wrote 1? Sorry, -1. Yes, -1, -1 and 1 by 2. Okay, so this is any 3, not only 3. Okay, any 3 rational numbers between -2 and 0. Now as same process you can do in example 7. You can do in example 7. Okay, so you can do it yourself. Example 7. Okay, same process you can use in example 7, that find any 10 rational numbers between -5 and -5 by 6 and 5 by 8. And in example 8 the question is same, find a rational number between 1 by 4 and 1 by 2. And yes, okay, and in any question you are not given that by this process or this process, okay, that by taking mean find three rational number between any two rational number. Not, you are not given that, like you are given only that, you will be only given that find a rational number between this or this, okay. In example 8, see, in previous examples 6 and 7, they are not used, sorry, they do not use this mean process, taking mean process, but in example 8 they use mean, okay. By taking mean they find given rational number, okay. So you do not require to remember, okay, that in this question you have to do this process or this process, okay. See the main question, okay, what will you be asked, okay, what are you be asked that, okay. So example 8 is the same thing, find a rational number between 1 by 4 and 1 by 2. So you can simply take mean of 1 by 4 and 1 by 2, and then you will have one rational number. Same example 9, find three rational numbers between 1 by 4 and 1 by 2. You can do that also. Okay, so this is the end of the series of rational numbers, okay. All the example are complete. Last 2 or 3 example you can do it yourself because the process is the same. So next videos are of chapter number 2, okay, chapter number 2. So stay tuned for, okay, for another chapter, okay, for another chapter. And the second chapter is linear equations in one variable, and in that chapter we will see how to solve these equations, and this is very interesting chapter, linear equation in one variable, okay. We will study what is variable, what is coefficient, okay. So stay tuned for chapter number 2, linear equations in one variable. And after that there is a chapter linear equations in one or more variables, okay. In second chapter we will see what is variable and how to solve it, okay. And we will see real life example, and we will use concept of linear equations in that, okay. So thank you for watching this video.